Assalamualaikum, my name is Aindala binti Muhammad Arif and this is my group members. Nur Laili Naam, Nur Afina Iwani, Nur Aina Ziwa, and the last one is Nur Sabrina. Today my group and I will be presenting about our case studies that titled Application of System of Linear Equation in Electrical Network. I will pass this presentation to Nur Laili Naam.
Introductions of System Linear Equations. System linear equations is the combinations of linear equations with M equations and N variables, or MXN linear system. There are two methods to solve the system of linear equations, which is Gaussian elimination method and Gauss-Jordan elimination method. Next, introductions to electrical network. Electrical network is a kind of network that delivers information on power sources. A current is pushed by a power source to flow through this network, where several resistors are reached, each of which demands a specified amount of effort to pass through the current. Systems of linear equations are used in electrical network to solve the currents and voltage through various branches of electrical networks, since various solutions of electric circuits such as the Kirchhoff law and Ohm's law are derived from linear algebra concepts theoretically. Next, I will pass this presentation to Afrina.
Next, we move forward to the problems. So in this diagram, the circuit A, B, C, D consists of 2 batteries and 4 resistors. The current flow in the circuit are unknown, so we let the current in the circuit as I1, I2, and I3. So based on the diagram, we have to determine the currents I1, I2, and I3 in each branch of the network. Next, by applying Kirchhoff's law of junction, meaning that all the currents flow in the circuit must flow out of it. The junction in this circuit is B and D. There are 2 closed paths, which is ABDA and CBDC, which following Kirchhoff's law of path, meaning that the sum of IR terms, I refer to current while R refer to resistance, in any direction around a closed path is equal to the total voltage in the path in that direction. Hence, we can deduce the junction and path as follows. Next, as you can see, the junction in this circuit is B and D. The current flows at junction B is I1 plus I2 equal to I3, while the current flow at junction D is I3 equal to I1 plus I2. We can conclude that the current flows at junction B is equal to the current flow at junction D. Therefore, I1 plus I2 minus I3 is equal to 0. So there are 2 closed paths, which is ABDA and CBDC. The current flows at ABDA is 2I1 plus I3 plus 6I1 equal to 6. We can simplify this into 8I1 plus I3 equal to 6. Moving on to the current at CBDC is 8I2 plus I3 equal to 12. And finally, we can form system of linear equation as follows. To solve this system of linear equations, we can use Gauss-Jordan elimination method. Next is steps for calculating using Gauss-Jordan elimination method. Basically, there are 3 steps which you have to follow. And the first one is, from the system of linear equation, you have to form an augmented matrix. And from the augmented matrix, you have to reduce it into reduced row equivalent matrix using elementary row operations. And finally, convert back to a corresponding system of linear equation. And as you can see, the first step is form an augmented matrix. Next, by using elementary row operation, reduce the matrix to reduce row equivalent matrix. Next, when the matrix is in the form of reduced row equivalent matrix, we can convert back to a corresponding system of linear equation. And finally, we can determine the currents for I1, I2, and I3 as follows. I will pass this presentation to Nurul Ainazira for result and discussion.
Now I will continue with the result of the discussion. By using the Gauss-Jordan elimination method, we can conclude current flow in each branch in the circuit. Hence, the current flow in each branch is I1 equal to 21/40 or 0.525 amperes, I2 equal to 51/40 or 0.275 amperes, and lastly, I3 equal to 9/5 or 1.8 amperes. Now, we will move to discussion. Electric current is the movement of electron through a wire and measured in amperes, AMPS, and refers to the number of charges that move through the wire per second. In this case study, we choose to use Gauss-Jordan elimination method to determine the current flow for each branch in the network, I1, I2, and I3, since it is more convenient and will give direct answer to each variable. Now, I will pass this presentation to Sabrina.
So, the conclusion is, in an electrical circuit, Ohm's law is the force or pressure that moves an electric current in the circuit so that it flows. This application can be shown in the electrical circuit when the current flowing experiences a voltage drop across a proportional resistor that obeys Ohm's law. Finally, linear algebra is important in our life because it really helps us to solve our problems. The scope of linear algebra is not only found in electrical circuit, but it is very wide.
This is the reference that we use for our case study. And that's all from us. Thank you.